Hello everyone, my name is Will Robertson and I am an education specialist assigned to the Marshall Space Flight Center in Huntsville, Alabama. Welcome to Summer of Innovation 2011. For the next few moments I would like to talk to you about planetary transits around extrasolar stars. Today's topic is the theme in Earth and Space Science, and the lesson is called Finding Earth-like Planets. The two activities that I would like to talk to you about will be detecting planet transits and counting your lucky stars. You know, you're aware of the fact that Earth is only one of 8 planets in the solar system, but in the last decade or so, astronomers have actually started to detect other planets around nearby stars within our galaxy. And these planets beyond our solar system orbiting other stars are referred to as extrasolar planets. The key word here is extrasolar. Extra, of course, means outside. In this case, outside our sun system, our solar system. We have a spacecraft at NASA that's dedicated to finding Earth-like planets in the galaxy. It is called Kepler. The Kepler spacecraft is a very sophisticated spacecraft that is able to detect a slight dimming of total starlight output when a planet passes in front of it. There are a variety of websites that I have linked in the lesson, Finding Earth-like Planets, that I encourage you to go to and really find out about the Kepler mission. It's a very exciting mission that is ongoing here at NASA. Well, let's talk about planetary transits for just a moment. A transit is when is when a planet passes in front of a star and the total star light output drops ever so slightly. And you cannot detect it with your eyes, of course. You could not detect it with ordinary telescopes, but you could detect it with the Kepler spacecraft. Now, when we have a planetary transit across the Sun, if it's Mercury and Venus, of course, we can detect, the disk of the blocking out of the sunlight from the planet itself, because the Sun is relatively close by to Earth. But distant stars, it's very hard to detect a dimming of the brightness of the stars unless you have the sophisticated instrumentation like we have on the Kepler spacecraft. But what happens is that when a planet passes in front of the star, in this case the Sun, you can actually see the speed of how fast Venus travels across the disk of the Sun. And this can actually be used by mathematicians, for example, to determine the orbital velocity of Venus as it goes around the Sun, and also how large the Sun is itself. So a planetary transit is simply when a planet passes in front of the star and the observer can see it. Here's the lesson, Finding Earth-like Planets. It is appropriate for grades 7 through 9. The complexity of the lesson is moderate, so it's not too difficult. But here's what happens in some of the lessons that you talk about. There are several lessons that allow the students to estimate the size of the planet as it passes in front of a star, as well as the period. And in this case, the period is the orbital velocity, or the speed of the planet around the star. What happens is this: when a star shines very brightly with nothing passing in front of it, Kepler detects just a steady light. But when a planet passes in front of that star, there will be a total drop of or droppage of the total light output of that star, and it will appear on a chart as a dip, as you can see here and here and here. And by determining the gaps between them, you can actually determine the orbital speed of the planet as well as the mass of the planet. And there is some mathematics involved here, but it's not too complicated for 7th, 8th, and 9th graders. To simulate a planetary transit, you can use this model where you have a light bulb and a ball on a string that passes in front of the light. Students will actually see a total droppage of light output from the light as the ball planet passes in front of the light itself. Another activity is counting your lucky stars. Now, you have to modify this lesson a little bit. In just a moment, I'll tell you how. What the students will do, they will each get a copy of this grid. And this activity is, you really need to have your students work in pairs, with one student holding a ruler as they drop this little square. Now, what they do is cut out this square and also cut the dashed line, and what will be left is a little window right in here. And then they will hold this little window up about 23 centimeters, which is about 12 inches, and they will drop it. And then wherever this falls, they will count the number of stars in it. And the premise of this is that for the case of Kepler, they wanted to look at an area of the galaxy where there were a lot of main sequence stars. A main sequence star is a star like the Sun, yellow in color, average in size, average in age, and so forth. So to modify this lesson, you would want to color probably about 30 of these stars of different sizes yellow, because those would be the stars that would be good candidates that will have Earth-like planets in orbit around them. So you would go ahead and have students find the average number of main sequence stars in a star field. And this activity is really a mode, mean, median type of activity, but it's very worthwhile to do. And it takes about 20 minutes or so to get the students to find out what is the total number of main sequence stars on the grid. Well, thank you for viewing, and hope that you have a very successful Summer of Innovation 2011.